This is lecture number 7 of the chapter Gravitation, and in this video we are going to understand what is gravitational potential. Of course, the topic is a bit different, difficult to convey you, but of course I'll try my best. And in the previous video we had seen about gravitational field intensity, how to calculate gravitational field intensity, right? Okay. After completing gravitational potential and gravitational potential energy, we will remove the gravitational field intensity, gravitational potential energy of different objects, so that you will clearly understand the concept. Okay. First of all, potential means a kind of energy, right? We have studied about potential energy, kinetic energy, right? So potential is a kind of energy. What is gravity? And yes, of course, potential in physics does not have any meaning. It is always the difference in the potential which is important, because difference in the potential will give you the amount of work done. This is what already I have explained you in the chapter work, energy and power, that it is the difference in the potential which is important, not the absolute value, right? Fine. Now, so whenever we are discussing about potential, right, we'll discuss about the potential difference. First of all, we cannot discuss, or we cannot say that potential at this point is this much. If you are saying it, you need to mention a reference point. With respect to this point, the potential is this much. This is how we should define it. Clear? Secondly, that gravitational potential, or while defining the potential difference, we will select a reference point. So that will be a convenient way to define the potential difference. So let us say that the reference point in our topic is infinite, right? So now if I am saying, okay, potential at this point is this much with respect to infinite, so infinite will be your reference point. Okay. Now, first of all, what is gravitational potential? Gravitational potential is defined as, we'll understand, first I'll write the definition, I'll write the formula, right, and then we'll understand it, right. We'll also derive this formula. Gravitational potential at any point, it is defined as work done by the gravitational force in bringing a body of unit mass from infinity to any point in the gravitational field without producing acceleration. Okay. What this definition says, gravitational potential is, basically potential means a kind of energy. Kind of energy means work done, right? So that is why we'll start this. That is why we'll define it in this manner: work done by the gravitational force, or of course in many books they are writing it as work done by the external force, negative of work done by the external force. You can define it in either of the way, right? There is no problem. We'll see both the definition and then we'll understand both the things, right? So it is work done by the gravitational force in bringing a body of unit mass from infinite, because I said you infinite, we are taking it as a reference point. So while taking a body of unit mass from infinite to any point in the gravitational field, okay, without producing acceleration. This is important. The mass which you are bringing from infinite to any point should not have acceleration. Only then the entire work done will be converted into potential, right? If the mass which you are bringing from infinite will have some acceleration, then a part of energy will be lost and the part of energy will be converted in kinetic energy. We don't want that. We want kinetic energy of the mass as constant. We want delta K is 0. That means the mass which you are bringing from infinity to any point should not have acceleration. The point is very important. Okay. What does this means? There is a body, so there is a mass, capital M, right? Okay. Now, Suppose unit mass, that is 1 kilogram. Let us say it is at infinite. Mass is at infinite. Okay. So we know that every body having some mass will produce this gravitational field, right? Every body who is having some mass will produce gravitational field. Okay. See, this is capital mass M. This is just our reference point. That means the unit mass is at infinite. Okay. Now, let us say that we are bringing this mass from infinite to say any point P, which is at a distance r. So according to the definition of potential, it is defined as potential at point P minus at infinite is equals to work done from infinite to P upon mass. As already I had explained you that we cannot point the potential, we cannot define the potential of particular point. We just have to write the difference, and for the sake of simplicity we have taken the reference as infinite. So at infinite potential will be 0. So potential at point P is equals to work done to bring the mass from infinite to point P upon mass M. Why upon mass M? Because it is saying that body of unit mass per kilogram, 1 kilogram. So this is a formula to calculate the potential. Of course, we will derive this formula, right? See, I have just explained you the definition and accordingly I have written the formula. Potential difference, right? Or you can say that potential at point P is defined as work done by the gravitational force or work done by the external force against the gravitation to bring a body of unit mass from infinite to a point P in the gravitational field. Okay, but the mass should not produce acceleration. That means when this mass is brought closer, the gravitational force of this capital M will attract this body towards itself. So it will move with increasing velocity. So then it will have acceleration. So this point is to be understood very clearly. According to the definition, we have said that the mass should not possess acceleration, right? And once again I am saying you that this is say capital M, 1 kilogram mass, that is unit mass is at infinite. Now the mass is brought to a point P which is say at a distance r by the gravitational force of this mass. But when this mass comes closer, right, the gravitational force which is F equals to G m by r square, as r decreases force will increase. So this unit mass will experience more force, and because of it will have increasing velocity. Velocity of this mass will increase, and if velocity increases it will have acceleration. We don't want that. We don't want a unit mass to have acceleration. So we will follow the procedure in which mass m will be moved very slowly and very small, right? That means I can divide this entire path so that mass m is taken from infinity to a point P in very small steps and it will not possess acceleration. Clear? If I am leaving this, then gravitational force will perform work on this mass and it will bring the mass closer to, or it will bring the mass at point P, but the mass will have acceleration. We don't want the mass to have acceleration. So let us divide the entire path and let us move mass m very slowly so that it will not possess acceleration. So now we will calculate that what is the work done by the gravitational force. What is the work done by the gravitational force in bringing a unit mass from infinity to point P? That will give me the potential at point P, because already we have defined that potential is the work done to bring a unit mass from infinity to a given point without having acceleration. So if I am calculating the work done by the gravitational force, to bring a body from infinity to a point P, that will give me the potential at point P. Okay, so now when 1 kilogram mass gets closer, R goes on changing. If R changes, F will change. So your F becomes variable. So whenever your force is variable, we'll calculate the work done by using integration. This is what I have explained you in the chapter work, energy and power. So let us divide this entire path into a very small segment, dr, 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 dr. So how we will calculate this? We will find the work done to move a unit mass by a very small displacement dr, and then we will integrate this, so that mass will not possess acceleration and we will be able to calculate the potential at point P. Okay, so work done, which is to bring the body from infinity to P, is equals to integration. We have studied now, work done is F dot dr, the same way, F dot dr to bring the body from infinity to point P, which is at a distance r, right? Okay, so what is this? Infinity to r, F g m 1 by r square into dr. The another was unit mass. Okay, okay. Now work done from infinity to point P is equals to gm constant infinite to r raised to minus 2 dr. What is the integration of x raised to minus 2? X raised to minus 2 plus 1 upon minus 2 plus 1. So work done from infinity to P is equals to gm r raised to minus 2 plus 1 upon minus 2 plus 1, so that is minus 1 infinite to r. So work done to move a unit mass from infinite to P equals to minus gm 1 by r infinite to r. So this is what is potential at point P. This is what is potential at point P, which is minus gm by 1 by r minus 1 by infinity. What is 1 by infinity? 0. So potential at point P will be minus gm by r, but the reference is at infinite. So actually we have defined potential difference, but the another point is at infinite. So the potential automatically becomes 0. So this is what the potential is, minus gm by r. The another thing which is to be noted is potential at any point is always negative. Other things, it is a scalar quantity. It is a scalar quantity and it is work done by mass. So unit will be joule by kilogram. Right? These are all the things which you must be of course knowing. Now this was the work done by the gravitational force in bringing a unit mass from infinite to a point, which is what we say as gravitational potential. But sometimes some definitions are given as work done by the external force. Now what is by the external force? That means, okay, see, this was mass m, right? Unit mass which was supposed to be brought from infinite to P. Now in this case, which is at a distance r, of course in this case V, that means external force, is not doing any work, right? It is the gravitational force which is bringing a body from infinite to a point P. Okay, let us reverse the situation. If I have been said to bring a unit mass from point P to infinite, now we require an external force, because if I am to take the body from point P to infinite, that is in this direction, then I have to apply the force against the gravitational force, because the gravitational force will be in this direction and I am to take the body from r to infinite, right? So this is what is my external force and this is what is my gravitational force. Practically, external force should be slightly greater than gravitation, but we can neglect these things in physics and we can say that the gravitational force and the external force will be equal in magnitude. They are just opposite in direction. So we can define the gravitational potential is such that work done by the external force to bring a body of unit mass from a point P to infinite. Right? The only difference will be potential will be plus gm by r. That is okay. This is when you are taking the body from point P to infinite. So when you are taking the body from point P to infinite, work is done by this external force, and when the unit mass is coming from infinite to a point P, then work is done by the gravitational force. So better, whenever you are writing the formula of potential, it should be negative, right? So you can also define in this manner the negative of work done by the external force to bring a body of unit mass from point P to infinite, or work done by the gravitational force to bring a body of unit mass from infinite to P. Choice is up to you. But at the end, the result will not change, and we finally got the formula that potential at point P, which is at a distance r from this mass, is minus gm by r, right? Now, whenever you are dealing with scalar quantities, the negative sign is equally important. That means as r increases, potential will increase. Make this point very sure. Potential will not decrease. I know many of them are thinking that why V is inversely proportional to R. If R increases, we will decrease. No, it will not decrease because it is having a negative sign. If it was plus Gm by R, then if R increases, V will decrease. But in this case, if R increases, potential will increase. I will give you an example. See, let us say that this is just an example. Let us say that numerator Gm is having a value 10, right? Just to make you understand, I know that Gm does not have the value 10, but suppose we will say Gm is 10. Once I am taking R as 2, then I am taking R as 5, right? Okay. Now, this is R1, so this is R2. Potential 1 minus Gm by R1. What is Gm? 10, so it is minus 10 by 2. So it is minus 5. Now, I am taking R2 equals to 5. V2 equals to minus Gm by R2. So it is minus 10 by 5, minus 2. See, clearly minus 2 is greater than minus 5. Right? So the negative sign, the role of negative sign is very important. That means potential increases by increasing in the distance. See, R2 is greater than R1. What we found? V2 greater than V1. Okay. Fine. Now, clear? Okay. Now, what if I am bringing a body another apart from unit mass? That means, if now I am bringing a body of say m kilogram from infinite to P, right? Now I am not bringing a unit mass. I am bringing any another body. That means 2 kilogram, 3 kilogram, 10 kilogram, 1000 kilogram. Then the work done to bring a body of mass m from infinite to a point P is defined as gravitational potential energy. Gravitational potential energy. The only difference between potential and potential energy is of mass. If you are bringing a unit mass from infinite to a point P, the work done is defined as gravitation. Work done will be equals to gravitational potential. If the body is not of unit mass, apart from unit mass, say 2 kilogram, 3 kilogram, then you have to multiply it by m. That will give you gravitational potential energy. That means for 1 kilogram, work done is equals to potential. Apart from 1 kilogram, work done is potential energy. So U is equals to m into V. This is again important because the same related formula you will learn in your 12th standard, which will be Q into V. Clear? So finally, potential energy between these two is defined as m into minus G m by R. This is capital M, this is any small m. Or let us take this as m1 and this as m2. So energy is defined as minus G m1 m2 by R. Clear? If m is 1 kilogram, then energy equals to potential, of course. Clear? So this was what gravitational potential and gravitational potential energy. If you are bringing a body of any other mass apart from 1 kilogram, the work done will be defined as gravitational potential energy. But if you are bringing a unit mass, work done is defined as gravitational potential. Gravitational potential is a scalar quantity. make sure that when you are bringing a body of unit mass, it should not possess acceleration. Clear? These are the formulas. This was the topic. Now in the next video, first we will solve the questions based on potential and potential energy, and then we will find the gravitational intensity of different bodies.